Hello everyone, welcome to grade 8 ICT. So today we are going to see the unit number 1, number systems. Right, so when we take the computer system, so we all need to communicate, right? So we take a computer, or if you take a human, we need to communicate. We need to communicate, right? So we need to communicate with this computer. But if you take a human, we can talk with the different languages. Right? We can talk with different languages like English, maybe Tamil, or maybe Sinhala. But what about this one, computer? What about the computer? When we speak in English to him, he is having a problem. What is this? Because he doesn't understand, he can't understand what you are telling to this. So he can only understand only Buddha, he can understand only ones and zeros. So they can understand only ones and zeros in the computer system. So to represent these things, we need a system for representing these numbers. So that's what we are going to see in this chapter number 1, number system. We will see now what is this number system about. And if we have decimal, we have 0 to 9, and it's having 10 in the base. If you have hexadecimal, we have 0 to F having 16 base there. Right? If I tell you a 1, let's see here. If you take this number systems, you can see a pattern. Can I just show you here how the comes in? Okay, we just say this is the number system. We just say this is binary, octal, decimal, and hexadecimal. In this one here, you can see in here we have the symbols. And if you take the base, right? So there are, you can see binary, we have 0 and 1. If you count 1, 2, there are 2 digits there, 2 symbols. So the base is 2. If you take octal, look at the octal number, Buddha. In this octal numbers, we have 0, 1, 2, 3, 4, 5, 6, 7. If you count all these symbols, you can see it's equal to the base. The base is 8. If you take decimal, you can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So if you count all these together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the base is 10 to them. But when you come to the hexadecimal, we can have here like 1, 2, 3, 4, 5, 6, 7, 8, 9. But we are representing the number 10 as a A. We have A, B, C, D, E, and F all together. We have 16 there. We have 16. Now you will see the number of digits. Number of digits or symbols are equal to the our base. Right? So number of symbols, yes, you can count and see. That is equal to the base value in the number system. For example, we say we have a system which is having 30 symbols. We assume that there's another system which having 30 symbols. So what is the base? The base also put 30. So you can see here the relationship number of digits equal to the base. Okay, you can see here another thing. If I put another column to here, adding called maximum column. For the maximum here, the maximum digit. So if you take the maximum digit of each of the number system here. Okay, dear. Each of the number system here. So you can see it's here is 1. Here is 7. Here is 9. Here is 10. So let's see what's the relationship between the base and the maximum. So you can find the maximum value or the maximum digit like this. So you can find any of the number system maximum by this way. Base minus 1. Let's see an example for this one. Now, if I take the octal number system, so what is my base to that? Here we have the base value is 8. No? Base value is 8. And if you minus 1, you are getting 7. Is that correct? Yes. So you can see in this octal number system, the maximum is 7, and you can take that from this equation. So you can see another one here. It's what? The number of digits is equal to the base value. All right. So we can represent the numbers using this number system. Right? So there are 4 number systems we are having, but we are discussing only few of them here for your syllabus. Right? So when you take your syllabus, so we want to see now. Right? So we are having only these number system we are discussing. Right? Okay. So we can see there are this relationship, what is that? Right? So we can see the base is the that represent the number system. So base value. Right? So we will see now the binary number systems we have in. Right? So we can see here, we have to see now these number systems. Okay, so we can see each of the base. So you can identify the base is mentioning under this is number. So this is 101 is the base 2 is a binary number. This is the binary. So if I represent 101 as an octal, you have to put the base 8. Then 573 is the base 8 we have to put. All right. So we will see now how you representing this number system in the counting frame. Right. So if you want to represent a number, so we just take an example here. Right. In this one, you can see now right? You can see now here. So if you expand 475, so you can put this in a counting frame like this. So if you 10 to the power 0, if you put it here, you can put 5 here. 1, 2, 3, 4, 5. Okay, so you can put it here. 1, 2, 3, 4, 5. So this counting frame there, this side, 10 to the power 6. Then for 7, for the 10 to the power 1, you are putting 7 dots. So you can put 1, 2, 3, 4, 5, 6, 7. And if you want to put the 4, you have to put 4 with the 10 to the power 10 next round. So 10 to the power 2, and putting 1, 2, 3, 4. And if you expand this one, this is the way we expand this 475, you can expand as what? 4 into 10 to the power 2 plus 7 into 10 to the power 1 plus 5 into 10 to the power 0. Remember, Buddha, if you take 10 to the power 0, the value is 1. So any number system, 10 to the power 0 is 1. So we can say it's 5 into 1. Here, 10 to the power 1 means 10. 7 into 10. 10 to the power 2 means 100. And if you multiply this by here, you are getting 400. And you are getting 70. And you are getting 5. So altogether, 475. And if you see another example here, the 1202, 8, you can see, and you expand it, this is the way we represent. So if you are asked to expand this one, this is the way we have to represent in the paper. When you write in this one, you can write like from here by how 1 into 10 to the power 3 plus 2 into 10 to the power 2 plus 0 into 10 to the power 1 plus 8 into 10 to the power 0. So calculate here is 1 into 1000, 2 into 100, 0 into 10, 8 into 1. So altogether you are getting 1208. If you take another example here, 2024, this is the way. How you do this, Buddha? Means here is where to take 2 to the 10 to the power 3 plus 0 to the 10 to the power 2 plus 2 into 10 to the power 1 plus 4 into 10 to the power 0. When you make it expand it, this comes 2 into 1000, 0 into 100, 2 into 10, 4 into 1. Altogether, you have 2024. If we take another example, this one, so you can see it's here 4726. You expand it, transform it. So you have to take it, comes here 4 into 10 to the power 3, 7 into 10 to the power 2, then 2 into 10 to the power 1, and 6 into 10. So then you are getting what? 4726. Okay, so this is the way we expand the value. So in your book, they have given so expanding this one. So this is the way you are expanding. Right? So we can expand this the value here. Right? So you can see this is the way we expand in the counting frame. Right here. Right. So let's see now how you represent these binary numbers. So binary numbers we can represent in this way also, in the counting frame. Right? So the counting frame we can represent in here the same way. We can represent. So it's coming here 1 to the 2 to the power 2, 0 to 2 to the power 1, and 1 to 2 to the power 0 like this. So when it's coming and then now 10. Okay, right? So if you see a number conversion, right? So we have to convert the numbers, right? So if you convert the numbers, this is the way expanding, right? So you can see. So expanding this way, we can represent. So this is the way. We can represent this in the counting frame like this. So always you start from this side, from your right side to the left side. So you have to go from your this direction. Right? So always you go from this one, 2 to power 0, 2 to power 1, 2 to power 2, 2 to power 3, 2 to power 4, 2 to power 5, according to the number. Now, after that, you take the value 2 to the power 5 into 1, because it has 1. If you take this one, it doesn't have anything, right? So what is that one? So it's coming 2 to the power 4 into 0, right? And the next one here, what? 2 to the power 3 into 1, and 2 to the power 2 into 1, and 2 to the power 1 into 1, for 0 here, 2 to the power 1. So likewise, we can expand the value. Okay, right? So to take this one, example, this one, you can see, so expanding this number, so you are getting the value of 11. So when you expand this one, you can see the value we are representing here is 11. And if you take this one, you expand it, so it's coming 2 to the power 6 into 1, 2 to the power 5 into 0, 2 to the power 4 into 1, 2 to the power 3 into 0, 2 to the power 2 into 0, 2 to the power 1 into 0, and 2 to the power 0 into 1. So when you get this one, you are getting as the 81. 81 is the answer you are getting here. Okay. When you expand another one, you can see. So in this note, you can see there are some exercises given for you all to do this. So you have to expand and see what are the values. So you can get this one here. All right. So the next one we're going to see is the conversion of decimal to binary. So when you want to convert a decimal to binary, you need to divide that number until it becomes 0 by 2. Because the decimal base is 10, the binary base is 2. So when you divide this one, so you can see, let's say this example, 62, I want to convert into binary. So when you divide this one, 2 into 3, 6, then 2 into 1, 0, but remainder there. Right? Then, so here we take this one, to divide the 31 is 1, remaining 1. The remainder you write in front of this. You write the remainder in front of this. Okay, so if you divide the 15, it's 2 into 7, remaining 1. To divide the 7 by 2, it's 2 into 3, 7, remain 1. Then if you take 3 divided by 2, it's 1 and remaining 1. To divide 1 by 2, it's 0, remaining 1. So you can see when you divide this number, you are getting the answer. You have to write, remember, this direction. That's the direction you have to write. Right? So don't write this direction, that is wrong. Right? Remember, when you divide this number by 2 to convert into a binary, so you have to write the answer on this direction. Okay, so you can see the steps here, how it will be. Now look at here. So if I give some example for you, right? So look at these examples, and this exercise is 109. How you divide it? Look at here. In this one here, if you convert this 109 into binary, so you can see we divide 109, it's 5, 2 into 5, 10. It means 0, 2 into 4, 8, remain 1. So you can write the remainder in front of this. Right? So you can write the remainder. Then take the 54. 54 divided by 2, you are getting 27, remaining 0. If you take the 27 divided by 2, it's getting 13, remain 1. Remainder 1. Then if you divide 13 by 2, it's 2 into 6, remaining 1. Then if you divide 6 by 2, it's 3 and remaining 0. If you divide 3 by 2, it's remaining 1. And if you divide 1 by 2, it's 0 and remaining 1. So final answer, you have to write in this direction. So the final answer you can write for the 109 is this. So you can write 109 is equal to 1101101 base 2. Right? The way. Then if you convert this number also the same way. So you can see how we divide it. Right? So once you write this one, so you can write the answer as this. So if you divide this one, 458 into binary, you are getting the answer as 1. All right. So then we can take another one, the final one, as here is the what? 1877 dividing, you are getting, this is the answer. Okay, so this is the way we divide or we convert a decimal number into a binary. Okay, are you all clear? Right. So this is the way we are converting decimal number into a binary. Right? Okay, kids, let's see your activities in your lesson. Right? In these activities, you have to complete these things using the word first activity. Fill in the blanks with the words given in the word list. Now we have learned the number of digits equal to the base. Now it says here what? The number system using 10 symbols, it's a which kind of a number system is now? So it's that one, it comes as a what? It's a decimal number system. So you can write here as decimal. Right? Then the next one, the base for this one is, you can see they have mentioned, what is that? 1001 base 10. So what is the base? The base is Buddha is 10. Then if you take the number system, black using symbols is this number system. What is that? A number system using how many symbols? 2 symbols. We call that as a binary number system. It's a binary number system. Okay. Then the last one in here, the number of symbols in a number system is what we call that's the base value. The base. Okay. Right. So this is the activity 1.1 in your first unit. Okay. And then if you take your activity number 1.2, expanding. So how you expand this one? So you have to write this one. If I write here, right? 528, 186, and 308. How you expand it? Okay, let's see this one. 528. Here we are taking first 5 into 10 to the power 2 plus what? 2 into 10 to the power 1 plus 8 into 10 to the power 0. Right? Okay. So when you expand this one, so you are getting here 500, here 20, here 8, 528. And if you write this one, it's 1 into 10 to the power 2 plus 8 into 10 to the power 1 plus and 6 into 10 to the power 0. To expand this one, 1 into 100, you take it, 8 into 10 plus 6 into 1. So what you are getting here is 100 here, it is 80 here, and the 6 together, 186. The last one, take it here, it is equal 3 into 10 to the power 2 plus 0 into 10 to the power 1 plus, right? And 8 into 10 to the power 0. When you take it now, it's coming 3 into 100 plus 0 into 10 plus 8 into 1. So you are getting here is 300. Here you are getting 0. Here you are getting 8. And the answer is 308. Right? This is the way we can expand the value here. Let's see the next one activity. It's to convert the decimal numbers to the binary. So we just write this one. The first one is convert. It's 1 point activity 1.3. First one we have 28. Second one we have 47 to convert. And the next one is 101. Okay. So those are the questions in the activity. So let's see now how do you going to convert this. So I told you when you want to convert a decimal number into binary, right? So we need to convert. That's the question now in this one asking. Okay. Convert the following decimal numbers to the binary numbers. So when you take it now, so you can take it like this. Right? So when you take it now, we divide by 28. It's 14, remaining 0. Right? Then we take this one. Five. Then there are 7 remain 0. Here 3 remain 1, and here 1 remains 1. Okay. So when you take it now, you can write 28 as 1, 1, 1, 0, 0, basically. Then write the answer in this direction. We take the 47, same way. 2 into 2, 4. Here 3 remain 1. If you take here, it's 1, 1 remain 1. Right? Then if you take here, it's 5. 2 into 5, 10 remain 1. Here 2 into 2 remain 1. And here 1 remains 6. When you write the final answer, you can write like this. You can write 47 is equal as 101. Right? and 1 0. 1 2 3 4. 1 2 3 4 brings 2. The last one, 101. Take it and it's 2 to 5 and here again. And if you take 50 divided by 2, it's 25 and remain 0. Take 25 divided by 2, it's 12, remain 1. And if you take divide 12 by 2, it's 6, remain 0. And if we divide 6 by 2, 3 remain 0. If you divide 3 by 2, it's 1, remain 1. Final answer, right as 5. Then 1 is equal to 1, 1, 1, 1, 2 zeros, 1, 0, 1. So this is the way you convert the decimal into binary. Right? So that's the activity 1.3. Right? Okay, let's go for your next activity. Okay. There's another one, 128. So how do you take 128? You take 128 and 173. Right? So let's divide this. We take this 128, right? 128. 128 we convert to its 3, 6 here, 4 remains 0. Here 3, 2 remains 0. Here 16 remains 0. Here 8 remains 0. Here 4 remains 0. Here 2 remains 0. Here 1 remains 0. So answer is 128 is 1, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. If you take the next one here, 173 converting into binary. So we take here it's 8, 2 into 8, 16, remain 1 for 13, 6, 2 into 6, 12, remain 1. Okay. 2 into 8, 16, remain 1. Then look at for 13, 6, 2 into 6, 12, remain 1. Then take 86, it's 43, remain 0. 43 remains 0. Then divide this one, 2, 21, remain 1. And we take here is 10, remain 1. Here it's 5, remain 0. Here 2, remain 1. And here 1, remain 0. So we can write 173 as 1, 0, 1, 0, 1, 1, 0, 1, base 2. Right, so that's the last two of conversion now. But the decimal to binary. Right. See the next one activity. So we have to convert this one. Convert the following numbers to decimal numbers. So how you convert that one? Right. Right. So I write the first one A. Right. Then I write B here. C. All are binary numbers. Yeah. Right. B. This we have 6 ones. Now with them. 1, 2, 3, 4, 5, 6. The last one we have It's this one. Okay. Okay, we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right? That's the last one. Right? So how do you convert this to decimal? So this is the way you can write here in front of here. This is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So you write the value of this 1 to the power 0, it's 1, here 2, here 4, here 8, here 16. So you multiply this one by this number. Okay, and you can take it here. Okay, right? We can convert. I'll show you one example here. You can do the remaining part. So if you take here it's 0, here 2, here 0, here 0, here 16. So answer is 18. If you take here, it's got 0, it's got 1, got 2, we've got 3, then we've got 4. Here we have 5. It is 1, here 2, here 0, here 8, here 16. So how much? 10, 20, 7 is done. Okay. So when you take this one, here, to the power 0, to the power 1, to the power 2, to the power 3, to the power 4, to the power 5, to the power 6. So here we have 1, 2, here 0, here 8, here 16, here 0, here we have what? 64. And so you have to add these together and get the answer. Right? So likewise, you can finish this one by completing this. So likewise, you can take the answers for these questions. Right? So we have come to here, and we can see now this last one. The last one asking, use the information in the illustration given below to answer the questions. Right? So you have to see this. Right? So you need to find it. Okay, now what they are doing. So what we are doing, I told you. So the computer we are giving instruction and convert into binary, then but it sends the process and it gets the answer. Right, look at here. As the computer, as the word ICT type in the data from the binary pattern, the system. So what is that one? That is number 1. This is the number 1. This is number 1. Okay, this is the number 1. Then what they say is the binary data saved in the computer memory flows to the printer and prints the word ICT. So whatever. So that is converted the word ICT and it goes to a printer, and this is the number 2. And what is that one? Finally, the binary data saved in the computer memory flows to the monitor and shows the ICT word. So here, what is the answer? If you come here, this will be the number 1, and this is number 2, and this is number 3. Okay. So likewise, you can complete the activities. Right? Okay, Buddha. Right. From here, we have come up to the end of your chapter number 1, the number system. So thank you all. Thank you all for joining the session, and we will see you next time with a new chapter. Bye for now.